Hey, good evening, everybody. Hope you're all having a good Monday. I'm sitting over here checking the microphone levels, just making sure everything is all set up for this evening. See a little contrail out there. This was an Alaska Airlines flight going from Cancun to Seattle. Up at 36,000 feet, I was able to capture a little bit of that. That was really about the only thing to see in the sky this evening. We've got a pretty warm weather pattern once again here in the central U.S. And let's see just how warm it's been. These are the high temperatures yesterday. And you can see we were looking at values widespread 80s across Texas and Louisiana, even 101 at Monterey. And the only area with cooler than average weather right there on the west coast. So highs in the 60s and 50s and 60s out in that area. And let's check out the 500 millibar chart here. This is the mid-level winds up at about 5 kilometers or about 18,000 feet. You can see kind of a zonal pattern here, also kind of a split flow. Northern jet running along the U.S.-Canada border right there, and then the southern jet going from about Phoenix in through the Dallas area and then up to about Virginia. So the highest wind speeds we're seeing are right there at Dallas. So jet max kind of in this area in the base of this trough here, and we can see that there's an upstream ridge starting to move into the area. So between the downstream trough and the upstream ridge, that's an area of anticyclogenesis. So we should see improving conditions here over the short term. And then we have more weather coming later in the week. Pretty good trough there, digging in here on the west coast. This is the satellite loop here. And as you might guess, this is infrared imagery. So we can see that hot terrain there in the Big Bend. These are probably 100-degree temperatures down here. And we can see a little bit of a fine line from about El Dorado down to San Antonio. So that's probably a little thunderstorm going up there, maybe a little front coming through the area. And this is important, what we see here, because often you can catch areas of convective development before they show up on radar. So here you can see a little bit of like a cellular appearance here and there along that line. And this is really where GOES R or GOES 16 will really help out, because it'll depict these fine lines in better detail. Some pretty amazing contrails here over Oklahoma. Another patchwork of them over Kansas. And then going into the Rockies. This is the next baroclinic system moving across the Rockies right there. And we can see this area here. That's a little bit of a dry slot moving into the backside of that system. So baroclinic leaf pattern, kind of like that. And then back in behind it, there's the dry slot. And then further west, that's where we're going to find the cutoff low, the upper level low. Or if I remember correctly, I think that might have been just an open wave. Yeah, that's what we got there, but there is some cold air in the middle of that. Okay, other patterns. What do we have going on at the surface? Not a whole lot compared to the past couple weeks. The thermal gradients have really started relaxing a little bit. A little bit of packing here in Utah, Nevada, and California. So that's probably on the back side of that front coming across the Rockies. So I'm going to go with that for a basic configuration. And let's go to the surface chart and see if there's any detail there. So down here in Texas, yeah, looks like we can pick out maybe a front right in this area here. So north of that, we've got some weak north winds, and south of that, some light south winds. In fact, you can see a little bit of a deformation zone right in this area here. So I'll draw this out real quick. You might have seen this in meteorology textbooks. But this is an area where we have difluence in this area, difluence in Houston, and then confluence in this area here, and then confluence on the other side around Memphis. And for severe weather forecasting, this is kind of relevant because when I see boundaries in this area, I find that when they're in the center of these deformation zones, like right here, they don't really seem to favor much convective development. Usually it's on either side of that. And then let's see, what else do we got going on? I mentioned the difluence to the north and south, so that's going to be an area of anticyclogenesis over Oklahoma and in Kansas. And then probably a little bit more high pressure along the Gulf Coast of around Houston. Do we find that front across the Rockies? Well, maybe. It's pretty weak. I might have to plot out the potential temperatures. Sometimes that'll help you out. So there's the potential temperature field. Looks like a little bit of a gradient through here. So maybe supporting a front in the Four Corners area like that. And then I think beyond that we would have to be looking at trends at each of these stations. Trends and continuity there. Okay, before we go on too much further, I think it is time for the microphone check. And I like to put up the dynamics before we do that. I don't know, it's going to be kind of a habit here, so let's just put this up real quick. And let's see, who do we got? 31. I think people are checking in for the severe weather thing. We're going to talk a little bit about an EF5 tornado, and I'm going to not mention the date right away, but that'll be coming up in about 5 or 10 minutes. We got Andrew, usually the first one in, checking in. Fred Reamer, Greg S. Finally caught one of the live weathercasts. Lexi is here. Ryan, Fun with Tech. Ahmed, Brian Harp, Ron Chalfont, Sue M. Dorothy Tornado from the Land of Oz. Mark Davis, and let's see, Alexander Williams, Brett Dean. Seeing some thunderstorms on the forecast there. Appalachia is booming tonight. Yeah, I'll have to take a look at the radar there. Eastern Tennessee and see what's going on. Jeff Day, Victor Cabot. Brett Dean says he's got bronchitis. I feel like I'm getting a little bronchitis myself here. Jason Boggs, not sure if heating will get going. Jason Boggs is up there in the Texas Panhandle, so he's thinking about going south along the dry line near the Guthrie and Paducah area. Ryan Toomey says a full train of systems rolling in off the Pacific. Alexander asks, what satellite do I use? In this case, this is just the standard GOES East satellite, and this is the source that I'm using right here. I'm using weather.msfc.nasa.gov, but there's a lot of other different sources I use, and I'll show you one. For those of you who have missed it, this is the new GOES-R data. So I'm trying to give you the GOES-R data. And I'm going to have to transfer one of my bookmarks over. But this will definitely be worth it because we'll be able to check on that fine line there. Okay, coming up here in just a second. GOES-R, of course, is the new next generation geostationary satellite. And there's some fairly dramatic improvements. And this is the website that I'm going to that's called KachelmanVetter.com. You'll just have to freeze frame that on the playback or take a note there. It's Kachelman with 2 N's and WEATHER. If you go down into the satellite menus under the satellite builder, you'll come up on this interface right here. And it's going to take some practice for a lot of you to use this because, for one, it's in German. But I'm just going to go through this really quickly. To get to the regional satellites, I go to this Nord under Rasterkarten. And when that comes up, I go in manually and zoom in here. And we're going to take a look at that fine line that's in Texas right now. Okay, so I'm basically zooming in a couple times. Okay, then once we go there, you don't want to have this alter up. This alter GOES. That's the standard GOES imagery. You can get that anywhere. What you want to do is go to the Super HD. The daytime visible imagery is down here. The infrared is up here. Tag und Nacht, that's day and night. So we're going to pick this top alarm, and that'll bring up the infrared. And there we are. That's the GOES-R imagery showing that little fine line from about Waco up to El Dorado, Arkansas. And let me scroll that out to maybe Tennessee, since I know there's some severe weather going on in that region. Okay, and there's our infrared imagery there of Tennessee. I've got it zoomed in on the Nashville, Knoxville area. And some of you might think, well, it's kind of low resolution, doesn't quite look like radar. Well, that's true, but check this out. If I go to this time bar in the lower left, where it says ZEET, if I click on the arrows, see that? We just went back 5 minutes. There's another 5 minutes there. So we're getting 5-minute infrared intervals here, which is amazing. We've never had that with the previous GOES imagery. And you can do that with the normal visible imagery and all that. So basically some really neat stuff there, and you can go on and play with that. So anyway, maybe that'll be a good thing to have a special workshop for. But for now, we're just going to have to move along. Okay, let's see here. Let's jump over to the dynamics real quick, and we'll see what's heading through the U.S. This is the upper air dynamics here for right now. There it is right there. So Texas is in between systems, and we're under this ridging. So the wave that we had out over Texas earlier yesterday, that's now over the Ohio Valley, and that's affecting Tennessee there. And here's the next wave coming in from the Pacific. So there's the large trough from Las Vegas southward, and lots of height falls in this area right here around the Four Corners. And that's where we're going to expect to find the surface front there. And then just a very quick look what's going to happen over the next 24 hours. Dynamics spill out into the plains, so thunderstorm chances go up on the plains tomorrow. Then the cold core low itself moves out over Oklahoma and Kansas. That'll move eastward, affecting Tennessee again. Here comes the next wave, wave number 4 for the weekend. And then wave number 5 coming in for Tuesday next week. And I bet that's wave number 6. Yep, there it is, digging in there over Kansas and Oklahoma. And wave number 7, so we've got a real train of weather systems coming up here for the next couple weeks. So let me move really quickly to the forecast, and then we're going to get on with the EF5 case event here. And I think we're going to look at the convective, actually let me look at the NAM here. I'm going to pull up the regional model for tomorrow because we've got this frontal system coming in from the Rockies. So the NAM model, this is basically the WRF. And I'm going to show you very quickly, when we get into a severe weather event like this, what I like to look at is the dew point and the wind field. So that's what I've got pulled up here. So you can see we're starting this at 18Z. That's noon this afternoon. We don't actually, no, hang on a second. Yeah, 18Z noon. That's the latest data we have. So there's the current data. You can see the front in place there. You can kind of see that deformation zone right in this region. So that kind of matches up good with the surface data. Starting to develop a return flow out over West Texas. And then for tomorrow, okay, so here comes the moisture for tomorrow. These are 60s dew points right there. So those are going to be working up the Caprock and up onto the Lubbock Amarillo region. So this is during the day. We can see a dry slot working in around Midland and Hobbs. So by late afternoon, the NAM, or I'm sorry, yeah, the NAM model is looking for a dry line, something like this. And I think this feature here, this is probably a little bit of a front maybe. So maybe a bit of a triple point right there along the Caprock near Lubbock, like around Dickens or Guthrie. So that's a possible chase target for tomorrow. And also in the weaker moisture up here, maybe a little bit of upslope flow from about Plainview up to just north of Tucumcari. So those are some possible targets for tomorrow. And then you can see this convergence along the Red River. So this looks like kind of a locally favored area for thunderstorms. You can see the wind flow, how the wind field is kind of oriented like this, south of that front, and then it's more out of the east, north of that. That's that confluence there along that front. So probably some backed photographs in this area and some enhanced helicities. So that's what I'm looking at when I'm checking out these charts for tomorrow evening. So what are we looking at for precip? Let's run the charts forward. Okay, so here's the overnight hours. There's 6 in the morning, 10 in the morning, and noon. Okay, so the NEM is breaking out some early convection around noon to 1 p.m. See all that? So probably not much capping here. So maybe some widespread convection. So probably a one play area here would be a long tail end Charlie. NEM is looking at maybe the Aspermont Guthrie area further down the Caprock. And then by evening, tail end storm down in the Vernon, Wichita Falls area. And that matches up pretty well with that warm front type thing. Maybe some enhanced helicity along that boundary. So maybe for targets tomorrow morning or tomorrow evening, just at first glance, I'm looking at that area right there according to the NEM. Okay, anyway, I know this is kind of dragging on, so let me just wrap this up real quick. Otherwise, we're going to be here all night. GFS forecast for the week going into this weekend. Here comes that first system. Precip overnight tomorrow night in Texas. And there it goes. After dark, development down along I-35 in Texas. And then the main low pressure system moves eastward. So front looking like this here. A little bit of high pressure moving back in behind it. Here comes the next system. So things look pretty quiet in the Great Plains until probably about Sunday here. So there's a development there on Sunday. Looks like a cold front down along the Gulf Coast. And then we see a bit of a squall line moving eastward on Monday next week. Next wave coming in from the Rockies, and there's that frontal system right there. That looks to be a little bit drier, but maybe some thunderstorm activity in Arkansas and Missouri on Wednesday. Here's the next system coming in for Friday the 7th. And it's probably too early. I mean, this is too far out to call severe weather potential. But anyway, it does look like storms for the southeast. And here comes what looks like a pretty strong front. You see the 540 thickness line coming into Nevada and some widespread snow there. So that'll definitely have an impact on Texas. And that moves eastward, and that's got a pretty good punch. And that moves pretty quickly into the southeast U.S. and a pretty good cold punch behind that. So, maybe we'll cool down a little bit around the middle of next month there. Okay, that was a lot of data to look at there. So let's check out that EF5 tornado. I'm trying to think which chart I want to go to first. Let me bring up this chart here. This is what the environment looked like over Oklahoma about 3 hours before this EF5 tornado hit. And I guess I'll go ahead and tell you where it is. This is the Moore tornado on May 20th of 2013. And it formed along this dry line right here. Let me go ahead and give you the the state lines. So there's Oklahoma right there, and here's the Texas Panhandle, and here's North Texas. So we start out with this dry line here, and you can see the hazy look to the tropical sector right here. Contrasts very sharply with a very clear dry air west of that dry line. And we zoom in and we can see that the tropical air is fairly well capped here, because we can see these transverse bands. So that's a good indication that things are pretty well capped. But you can see we're getting these towers starting to go up around the Lawton area. Then we have these other towers near Chickasha and Anadarko get going later on. And I've only got one other satellite frame right now. I don't have the go set for this date, but this is the other polar orbiter image. And you can see Oklahoma City right there, got one good storm over that area. In fact, the Moore storm is right there. And then we have other storms near Walters and Wichita Falls further south. And if we go and zoom in, looks like we can see a little bit of the flanking line here on that supercell, because Moore is located right here. So we can see some amazing structure here, and GOES-R will give us some resolution close to this. And that's very important for these boundaries here before the storms actually form. So this clustering here that you see, that's really critical when you're forecasting and looking for development. When you see that going on right there, that's a good sign that your cap is about to break. Okay, let's switch over to the radar and look at things. And let me back up here. I'm going to go to about an hour before the tornado. Okay, we're loading up the radar data here, and let me just take a look at the chat and get caught up here. I don't think I'm going to be able to read all these messages here, but I'll just take a quick look here. Mike Estwick asks if that was digital atmosphere I was using earlier. Yeah, I was using that for the surface charts. College of DuPage just does not have GOES-16, to my knowledge. They've just got the standard satellite imagery. And then there's some discussion here about Fort Smith. Anyway, I'm going to go ahead and press on here and look at the Moore tornado, and this is still loading. But while it's doing that, I can look at some charts for earlier in the day. This is these are the maps from the Weather Service showing the upper air charts. And this one here, this is actually from Canada. So that's that's not very clear there. Let me try to find a good chart here to use. Yeah, here we go. This is the 200 millibar analysis. So this will give you a good idea of what patterns to look for in a severe weather outbreak. This is for this EF5 tornado and more. So this is 12Z. This is earlier during the morning hours. And this is up at 200 millibars. So this is up at 39,000 feet. almost the top of the troposphere. So we can see this large long wave trough. Not a very deep trough. You don't see this big cutoff low. We were talking about this yesterday. Nothing like that, just kind of a big open wave. And within that open wave, pretty good jet going through the base of that trough. We can see 75 knots here at 200 millibars. So that's the polar front jet rounding the base of that trough. Here's the 300 millibar analysis. I don't like that grainy look. I think the slide viewer is doing some resampling. Let me see if I can fix that real quick. Okay, I'll see what that does right there. Nope, that's not looking very good either. Anyway, yeah, this will work here. This is the 300 millibar analysis. So this is 30,000 feet. And this is showing that polar front jet extending from Albuquerque up to Wichita and then up to Iowa. And Moore is located right there. So they're just south of that strong jet streak. And you can see the winds aloft. They're about 55 to 60 knots. And then upstream here at Amarillo, showing 85 knots there. So some fairly good winds upstream moving into our target area. Then this is the Canadian 500 millibar analysis. This is kind of a mess to work with. Anyway, there's that. I'm going to skip that real quick. And then this is the 500 millibar analysis. And a lot of you are used to this because we show this every night. So let me get that recentered. There we go. 500 millibar analysis for the Moore May 20th event. There's Moore, and you can see the 50-knot wind right there at Amarillo and around the Blackwell area right there. So pretty much under the polar front jet there. There's some Canadian charts here. Here's the 700 millibar chart. And this can be important for kind of showing where your capping inversion is. We can see that the temperature was 9 Celsius at Oklahoma City. That's strong, but it's not super strong. A nuclear cap is when we're talking like 12 to 13. Of course, that depends on your low-level temperature and winds, but 9 is kind of optimal for a tornado situation. And we can see some fairly dry air aloft. 17-degree dew point depression. And then we can see the 700 millibar winds are about 25 knots out of the southwest. Okay. Then that brings us to the 850 millibar chart. There's the 850 chart, and do you know what we look for on this? We look for the low-level jet. I was trying to pan this all the way south, and I can't quite do it. Let me fix this. Hang on just a second. I'm going to have to reposition the monitor capture. Let me do that real quick, and then we'll be able to see Del Rio. There we go. I'll pop that just south a little bit. And there you can see that 30-knot wind there at Del Rio. So this is kind of the low-level jet coming up from that region up to Oklahoma City. And of course, a few more radio sound stations would help. But a lot of people forget that we have WSR88D data. We have VAD wind profiles. So you can go to Dias and fill that in. You can go to San Angelo, San Antonio. You can fill all that in. So that'll help you kind of isolate exactly where that low jet is located. And then moisture depth, that's the other thing I would look at. These are dew point depressions here. So we're talking about 850 millibar dew points here of 5 Celsius, which is about 41 at Oklahoma City. And that comes up to 14 at Fort Worth, which is about 58 Fahrenheit. So definitely some better moisture just to the south. And that increases to 17, which is about 63 here at Del Rio. So plenty of moisture upstream. So these are just some things we would look at maybe on a severe weather day. These were the high temperatures the previous day, but you can see lots of hundreds there in Wichita Falls. And I think all of the other charts are not really related. But I do have this set of charts here from SPC. This is really neat. This shows you the surface vorticity and divergence and the wind field. So this is 17Z. This is about noon. This is about 1 or 2 hours before the tornadic storms developed. And you can see the area coming together here. There's kind of this wind flow coming together. It looks kind of linear here so far. But then in 18Z, you can see this point convergence setting up here. The red is surface convergence. So we're setting up that, this is about 1 or 2 hours before the storms form. And point convergence is really what's optimal for tornadic storms, not linear convergence like what we have here. Then after that, things become kind of overwhelmed by initiation. And now the data around there is not really valid because it's basically contaminated. Kind of like my voice right now. Okay, let's see if that radar data ever loaded. I think it did. Okay, so this is just before initiation. You can see the storms around Lawton have gone up. This is what's about to go up here. So we're going to focus on that here. So we run this forward. This is 1:31 p.m. So we see one of our first cells going up near Chickasha. Here's another one right here north of Chickasha. And more is located right here. And now we're just on the edge of thunderstorm activity right here. So things are about to get busy. Okay, now I'm going to load up the second set of radar observations. And I'll take a quick look at chat while that's loading. David asks if when TVS pops up on JR level 3, is that automatically placed by the radar or by a human? That's by the radar. That's an algorithm. That's the tornado detection algorithm. And looks like one of our viewers, Jason Boggs, answered that also. And Ryan pointed out 2 other F5 tornadoes No, actually 2 total. F5, we had the May 20th and the May 31st tornado that hit Carl Jung and Tim Smarris and his son. And also May 19th, that was also a big tornado day in the Norman area. So this was a really bad event. Really bad episode. So now here's our Moore storm coming together. Starting across the Canadian River right there. I-44 basically runs like this. So this is closely following the path of the May 3rd, 1999 storm. So let me zoom in on this, and I'm going to show you the storm relative velocity. Okay, what values do I have set here? Sometimes you have to kind of play around with this storm relative velocity. Looks like nothing too significant in that right now. Let me shrink this down so you can read the velocities down on the bottom. Yeah, see down here you can read, right here. This is the actual velocity right here. This is the maximum unambiguous velocity. It's basically the speed limit for this VCP. So what you're looking for is this number right here. This is what it's showing underneath the cursor. And you can see when I put it on that storm here, we're only seeing about 20 knots outbound. Nothing too worrisome. So I'm going to switch over to base reflectivity again. Now what do we have aloft? I'm going to go up to higher tilts. And we see the normal tilting down shear. And maybe a little bit of rotation aloft here. So maybe we need to start looking at velocities aloft. So we go up there, and yeah, you can see a little bit of convergence here, a little bit of rotation. See these inbounds right here and these outbounds. We've got about 57 in and about 10 out. And this is up at 6,000 feet, so this is still kind of in the area just above cloud base up into the mid-levels. There's 3.2, there's 4.0. So you can see we definitely have some velocities developing aloft, circulation up there. And it really picks up here at 20,000 feet. We've got 101 knots inbound. Actually some pretty good shear there. Look at that. It's almost like a little bit of a tornado circulation aloft. 27 out and 86 in. Let me adjust this a little bit. Okay, that's a little bit better. I'll set that dot right there, and you can check that out on the reflectivity. It looks like a little bit of maybe a beware in there. So a lot of very dynamic stuff going on aloft there over Bridge Creek, even though the low-level tilt here is not showing very much. Not even a reflectivity gradient, really. So you can really be fooled here, but there's actually overhang. So from 0.5 to 5.1 and 6.4, there's that overhang right there. And then 8.1 and then 10. Yeah, see that right there? That's the vault right there. That's the beware. I'll set a dot right in there, and we can check that out one more time on storm relative velocity. Looks like maybe some rotation around that right there. Okay, let's bring this forward now. So now we know that there's something to be concerned about here. We'll skip a couple of scans here. The storm is crossing over the Canadian River. And we're starting to develop maybe a little bit of a hook here. Storm relative velocity. Showing some pretty strong outbounds here. Got about 35, 37 here. outbound, and there's some range folding in here. But if we can you see how granular it is in here? It's kind of noisy. When you see that, just go up to 0.9, just go up to a higher tilt, and sometimes you can get rid of that. It doesn't quite totally get rid of it, but when we get up to 4.0 and 5.1, you can start to see a little bit of that meso right in here. Okay, we're going to go forward a little bit more. So now you can see a very definite hook echo developing here. And there's the tip of the hook. So that's very unmistakable there. What does the storm mode of velocity look like? Okay, now we've got some serious business going on here. We've got 37 in and 49 out. Very close to each other. So we've got the smaller scale tornadic circulation, and then it looks like we've got this larger scale meso going on. And if we go to higher tilts, we can pick up a little bit more of that tornado circulation, a little less obstructed. I'll put a dot right there. Switch over to base reflectivity. We're up at 1.4. Right in the middle of that ball right there. This is up at 2,700 feet. Spectrum width, not showing much of a debris ball, anything like that, but this is kind of interesting. A lot of high diversity in here. This could be maybe a mixture of hail, maybe some inflow dust being advected in. It's common to have these higher diversity values out in an inflow region. So that could be what's happening there. Yeah, that's what that is. Then let's go up to some higher tilts, 1.8, 2.5. Still picking up that tornadic looking signature, but you see this wider scale meso here. So a lot of motion at different scales going on here. Switching over to reflectivity. Yeah, this big meso is taking place way out here, south of the main updraft. And we go up to some higher tilts, and we get up to the top of the storm. Okay, so there's that right there. Let's go up to the next. Let's go up to the next frame. You can see it's about to cross into Cleveland County here, coming into the Moore city limits. Now you can see things are really bad here. And the reason the reflectivities have really come up on the tip of this hook echo is because of debris. You're starting to pick up sheet metal and stuff like that. Spectrum width's also starting to come up pretty good there. And then storm relative velocity, that's looking pretty serious also. So you see that right there. And we're talking about a diameter on this circulation of only about half a mile. So that's well within the tornadic range. And then we've got this very strong component going into that circulation. So to me, that's kind of a red flag that things are... This is kind of a... I want to say tornado genetic, but in this case, maybe more... It's more along the lines of augmenting the circulation. That's what's going on here. And you can see that this is 53 knots away. In this region right here, that's the inflow feeding into all that. So thing is kind of like a big vacuum cleaner, and you can see we're kind of seeing a little bit of the what might be some boundaries here near the tornado circulation. And you can see they also put out a tornado emergency product here. So tornado emergency there for more large and extremely dangerous tornado. So here's where things are starting to get bad for more. The city itself located right there. So this is almost following almost precisely the track of the May 3rd, 1999 tornado. Now, when we start getting kind of close to the radar, I kind of like bringing this up to 0.9 because that gets rid of some of the clutter. So you can see it's a little more, well, it's not too cluttered there, but I still like using the 0.9 anyway when it gets that close, within about 20 miles. Then we bring that forward a few frames, and now we need to load up the third and final set. And this is where the majority of the damage is taking place and more. You can see that dust ball we have there is very large, easily a mile wide. And this is basically the debris cloud. And a lot of discussion and chat about that. Unfortunately, I'm not going to... I could sit here and read the chat, but I would probably put you all to sleep because it would take me about 5 minutes to get through it. But anyway, yeah, there's the tip of the hook. This is the tornado right there coming into more. And this here is the updraft area. And then the rear flank downdraft back in this area here. And then this is the forward flank downdraft just north of that. I'm going to get rid of these warnings for now. It's kind of obvious what's going on, so I'll get those out of the way. And let me put the highways on here. There we go. So I-35 is right there. I-44 is there. And this, I think that's 144th maybe. South 37th. I don't really remember all those streets. Okay, so this is when the majority of the damage has taken place and is going through the neighborhoods there, unfortunately. The debris ball really expanding there, spectrum width. Not much spectrum width there, but storm relative velocity. You can see some fairly high values there. We've got the 64 in and 87 out, so this is about a good 150 knots of shear there. And then masked within this is some fairly strong inflow. Very noisy returns, but that is the inflow right there. And we go up to higher tilts, and you can kind of see even more of that. And then we can also take a look at the reflectivity and go up to higher tilts, 0.9, 1.3, 1.8, 2.4, 3.2, 4.0. This is interesting. Kind of looks like almost we're seeing the core of the tornado. There's that little weak donut shape. That's kind of interesting. And then let's see, we go up to higher tilts, 10.1, 12.5. This is up at 13,000 feet. And then this is up at about 20,000 feet. So anyway, how would you forecast this? Maybe you're out east of here and you're trying to figure out if your house is going to be hit. This is where GR level 2 here really helps. For example, what you can do here, I'm going to zoom in on this couplet here and go back a few frames. Let me load up a few frames before that. Give me just a second. because that's one thing we don't really get into too much as far as techniques for determining motion. But there are some really good tools in here that are underutilized. And I do this all the time when I'm forecasting severe weather. Now, to find motion, a lot of people will use the storm tracking products, things like that. But why do that when you can actually see the couplet? So if you've got your couplet on here, you just take measurements of that. Let me advance this a little bit. Okay, so here's our couplet right here. I'm going to set a dot right there. We'll go forward a few frames. And you can see that our new position is right there. And we've got a readout down in the bottom showing the azimuth for that track. We can see that it's 68 degrees. So if we want to know who's under the gun, just extrapolate that 68 degrees to the northeast. So basically you're talking about anywhere from here back to the circulation. Now, of course, you are going to get oscillation in the storm, oscillation of the tornadic circulation. There's no way to really predict that, but the important thing is this will give you a baseline of which areas are most likely to be in danger. Let's see how that 68-degree measurement played out. We do a measurement 75. Okay, that's within 6 degrees. So this is a fairly good technique you can use. Even if your storm is not tornadic right now, you can skip down and look at other storms in the area to see what they're showing and then apply that to your storm. So those are some things you can do there. So anyway, after that, you can see the tornado moved across I-35 and then moved down this road here. Still some pretty good circulation there. It looked like 120 knots of shear. And then we get to the end of that sequence right there. So anyway, that was some stuff to look at. That's the Moore storm, and I'm going to kind of close that with a couple of slides here. Not slides, but a couple of photos. These are from my archives. This was a view outside my workshop in Norman. This is of the May 20th storm with the F5 tornado. That was a good 12 miles to the north, but you can see it there. And then on TV, this is what they were showing on the live news. And they were showing this only about 15 minutes after the neighborhood there got hit. So you can see how extensive that damage was. I mean, look at that. It's almost like 2 blocks from one side to the other. And of course there was some good mammatus, and the sky was lit up by cloud air, cloud-to-cloud lightning, almost continuous. And of course I did not go out and chasing that stuff. I think you got to be crazy to go out and try to chase in city traffic. Some people will do it, and some people are good at it, but that's not my idea of fun. And there's the Moore storm heading off to the east. And I wanted to show you this real quick. This is the same neighborhood that got hit afterwards, and this is an example of damage from the May 3rd tornado. And you can see the studs there on the bottom of this building. A lot of the slabs here were swept completely clean on the May 3rd event. There wasn't even these studs left here. So here you're looking at probably F3 to F4 damage in this case, probably F3 here. So this is what people like Tim Marshall do, Jim Ledoux and those guys. They go through and walk the neighborhoods and they look at damage and kind of map that out on a house-by-house level. And this really shows you the value of reinforcing the walls, because they found that a lot of homes in this May 3rd situation, they were not bolted to the slab at all. These are supposed to have lag screws, lag bolts going into the slabs, holding the studs down, which in turn holds the wall. And there were quite a few homes that were missing that, so you basically just had the frames sitting on the slab. And of course those were gone with F2 and F3 damage. So I'm going to show you what this property looked like several years later. I've got a screenshot set up. Okay, it'll take me just a second. Yeah, there it is. This is that same house. They rebuilt on the lot there. This is a look in the same direction, everything. So you can see quite a change there. Now, I don't know what happened to that. I guess they probably made it through the 2013 event just fine, because this is November 2015. I guess, I don't know, they could have been hit and rebuilt, but no, there's this tree here that's that's been there a while, so I think they lucked out and didn't have to go through round 2 here. So anyway, that's about all I got for this evening, and let me just take a quick look at chat. Hope you all enjoyed the webcast, and let me just take a quick look at the discussion. And I do apologize that I can't read all this. It's just too much, but hopefully that'll give you all some stuff to look at. Maybe we'll do some more of these over the next week or so, since we're getting into spring. But I think tomorrow we're going to be looking at this next event coming out of the Rockies, and that'll keep us kind of busy there. So yeah, we'll definitely check that out and bring the weathercast up. And again, we're going to be looking for maybe some activity in West Texas on the Caprock, maybe around the Lubbock area, up to Amarillo. And then that'll move eastward into the I-35 area after dark tomorrow. So anyway, thanks for joining, and we'll see you all at the same time tomorrow.